So we talk about the names, most of the fundamental things. So that's a fundamental， 这基本就是 the net 啊。那 the net 是 2 plus 3。So what's the AxNet? So AxNet here. So right now, almost all of this one backbone encoder the backbone are based on the concept of AxNet. What's the concept of AxNet? 5 plus 3. The net 5 is 2 plus 3. So that's meaning it's not deep enough. So the net 5 is not deep learning. The net 5 is not, it's just convolutional, neural network. They use convolution instead of the fully connected. The net compared with the traditional AI neural network is traditional neural network. They use fully connected network. 它们全部连在一起。The net, they use convolution. This means filter. They use filter, a concept filter, become convolutional network. That's the net. Okay. And it's not deep. It's just convolution. So the first deep neural network is AlexNet because it has a five layers. So that we call as deep. And VGG16 we call very deep because VGG16 has a 13 plus 3 neural network. So 13 we call is very deep compared with the deep. So here is very deep. And after this one, because we already call very deep, so we just say, deep learning of DNN, deep neural network, even though it's more deeper. 因为你已经 deep 了，你 very deep 了，你再怎么讲，你不能讲 very deep， 怎么 deep， 所以这里我们就不再强调那些东西了，就都称为那个 deep neural network 这样子啊。好，那我先继续讲一下 AxNet。所以 AxNet 是主要是 backbone 的最基本的啊，就基础开始成型了。那 AxNet why is famous because they attend the competition of this one， 他参加比赛嘛，然后得名的嘛啊。那实际上得名还没有那么有名呢。为什么会有名？事实上是因为那个下围棋那个 IBM 下围棋赢了以后，人家才把这个追回来。哎，发现他之前在这里就已经赢了这样子啊，所以是下围棋超过人脑才有名。所以他虽然2012年发表这个，2012年发表，我们有注意，但是还没那么有名，是因为那个下围棋赢过人，哎，第一个是下象棋，在下西洋棋，在下围棋赢过人家才开始注意到这一块，所以再回来追溯这里，所以真的大量的人进入这个 deep learning 的东西是在2014开始，2014跟2015，所以你会发现2014年和2015年之前的2012、2013 paper 还是不多，是2014年、15年才开始爆发很多这样子。OK， 那我们回到这一边，所以他参加这个比赛，那赢第2名赢非常多这样。So right now, for the AxNet, the one important thing is the pre-processing, 前处理。So here, they do pre-processing. So what's meaning for the RGB3 channel? Okay, for each image, you need to collect all the R channel and then subtract with the average R, average G, and average B for each image. So they do pre-process. That's important. And some paper not only do the subtraction, they also divide it by standard deviation. Okay. So here they just subtract with the average RGB. But later on, for each pixel, they are not only divided by subtraction with the average value, they also divided by standard deviation of R and G and B individually, 个别的. So become what? Become normalization. Okay. So that's look like a univector things. And for the AxNet, okay, this is not easy to see. I will use this one and go back. So AxNet is this way. 这我实验室做的哈. They have a five convolution, so extraction 5 times. However, they only downsample 3 times. So the original image 227, and they do extraction and downsampling 1 time, downsampling 2 times. Sorry, 1 time, 2 times, and 3 times. 它是前面3层做 downsampling， 因为已经很小了，它不再做 downsampling。但它有5层。但记得 after AxNet, we can have a more larger input image, so we have 5 downsampling. After AxNet, VGG16, VGG19, or ResNet, okay, they have a 5 downsamplings. So we have, but back to here, AxNet have 5 layers. So 5 convolution, but only first 3 has downsampling. And then after this one, there were 3 layers for the neural network, the same as the net. So this for the AxNet, we call 5 plus 3. X 是第一个5加3层的，这样子。Okay. But here, because the GPU is not so powerful at that time, so they use the 2 GPU. So that's why they have a 2 network. 是这个原因啊，因为 at that time GPU is not so powerful, so they use 2 GPU. They use to process. So they have a 2 network, and between some layer they do crossover. But actually, they still have a 5 plus 3. Okay. So this is a 2 GPU things. But right now, okay, right now if we use AxNet, you don't need to use 2 GPU because GPU like a 1080 is already powerful compared with this one. So we don't need to use 2 GPU, just use 1 GPU. So it's 5 plus 3. But remember, okay, when you do the deep learning, don't use AxNet because that's already not good enough. So, but you can use this one. You can use VGG16. So right now, when you try to use deep learning, don't use this one. You can use VGG, can use GoogleNet, can use ResNet. 就这边你可以这边都可以用，这边以后都可以用这样子。Okay, so back to here. Okay, and this is the loss function. And this is the ReLU here. Okay, so you can use ReLU. So what will we try to explain, say to you is that one problem is a managed problems. Previously, the net is just tell you the fundamental things, 就基本东西、基本概念，都 network 的东西。那这也要跟你讲，是因为它已经有点算有点深那个 deep 了啊，有点 deep， 就很多层了，所以会出现 vanish problems。What's vanish problems? It's because when you do the gradient descent, and finally all the parameters value are 0， 会出现这个问题，就避免你的 gradient descent 值变没了，那怎么办？所以就出现这叫 vanish gradient or vanish problem, vanish gradient problems because your parameters 被 propagation 一直微分，然后一直累乘嘛，一直乘一直微分，啊，就会变成，因为越小数点越乘会越小 ，fraction 啊 ，because your value is fraction and fraction time fraction time fraction will become very small， 它就消失掉了。这时候你会遇到一个问题，什么问题？那你的小数点要你 usually use float or double， 对不对 ？When you announce your parameters W and B, you want to use a 8-bit, 16 bit, or 32 bits, or 64 bits. But if you have more bits, you'll be slow. Your computation will be cost higher. 会遇到这个问题啊，所以你要考虑，这要考虑哦，不是不要考虑哦。那你有不，我讲这个不懂的话没关系，就问一下那个资讯系的好朋友。好朋友就是常常问，就会变成好朋友这样子。好，这边所以会遇到这个问题。So here is if you don't do anything, and if you have more deeper 9 layers, you'll find finally your accuracy will reduce. You'll cause the problems if you don't do any process. Okay. So that's this one. So how can we do that? And how can we solve these problems? So one problem is, one solution they do this one. The second solution they use a batch normalization. They don't say here. You normalize batch normalization. 这一篇 paper 没讲，因为 batch normalization 后面才有。Okay. And here they talk about this paper talk about LRN. Actually, we don't use this one because later on paper say this is not good, so we just forget this one. They try to normalize. They try to normalize parameters, but right now we use the batch normalization instead of others method. 用 batch normalization 这样子，就把 normalize 成0，你就是每次微分完你用 normalize 0到1嘛，再把它就是你微分越小，把 normalize 0到1，然后再每次就一层要再 normalize 0到1这样子。So batch normalization is help you to avoid the vanish problems. Batch normalization can avoid the vanish problems. So right now you'll find out after convolution, they do batch normalization and they do activation function, 3 parts. Right now, even though you do the same layers, but right now you'll find out the same topology. What people do is we do convolution, and then we do batch normalization, and then we do activation function, 3 be one module. 3个变成一个模组，现在几乎都这样做，没有100%，但大部分都这样做。以前只有 convolution 就没了，一直 convolution 是 convolution 啊 ，the old one is always convolution。然后之后又加一个 activation function 进来，那最后才 softmax。So you'll find the paper is this way. All the paper only convolution, and the final output they use sigmoid or and then softmax. That's all the paper. And previous, just 3 years, 4 years ago, okay, they use a convolution and then random. So they have a more activation function inside. They solve some vanishing problems. And right now, this recent 1 or 2 years, people do is a convolution, batch normalization, and random or liquid random to be one module to solve the vanishing problems. 这样子，好 ，OK。这我提过，就跳过去了。这个没什么。And next one, we will try to say overfitting problems. What's overfitting problems? It's because you have a large parameters, but your data are not big enough. So we previous lecture we talked about suppose your data are not enough, big enough. How do you do? The first solution we use augmented reality to create more data, right? So we don't have enough data because your network become deeper, parameter become more, so your data is not enough. So first solution is to try to create, based on the current data, create more data with augmented reality. 所以 augmented data 就把 data 量增加10倍嘛，那是第一个方法。Second method, we just talk about the hair, the boy and girl things, right? So we can have a more deeper. 这是第二个方法。那这些方法都是为了解决什么问题 ？overfitting 问题，就 data 不够的问题。因为 data 不够会产生 overfitting。那什么叫 overfitting？ 我们先讲 What's overfitting？ 就这里。Overfitting is this one. This one. Suppose the best function is a red one. 这条曲线是最好的曲线，我们希望。And each dot sample is the data you collect. So if the data you collect for those samples, and how can we use optimization to find the best fitting line, the red line? So sometimes if our data is not enough, that's meaning 我们 data 不够多嘛，那曲线那个曲线曲度比较大的时候，那几乎每笔 data 都很重要，对不对？ When your data are not enough, but your dimension very high dimension, so each sample become very important. So that's meaning because each sample is important, so each sample I want to, my solution should put this one, each sample put inside the curve and the function become output is 0. 什么叫 function？ 就是我们简单讲 ，function ax 假设 ax 加 by 嘛 ，x plus by become c is a line 条线嘛。那什么叫 fitting？ 就是我在线上每一点只要输入这个线这个 equation 的值就等于0，就 fitting 了。对 ，x plus by equal to c. I want to find a, b, c. So the best solution is that if each point is at the line, and I put those points inside the equation, exactly matching the line equal to z, that's meaning 0, and I can solve A, B, C. But in reality, the sample have a noise, so they will not on the line. They are already off down. So real data 是这样子。So you need to want to fit this one, right? You need to higher dimension curve. So probably ax squared plus by squared， 就 ax 平方加 by 平方会变成2次式嘛。 来 fit 它嘛。但是这个越多你要 fit 这个越多的话，就越多，这 order 就越大嘛。这是 order 的是这个蓝色线是 order 越大，你就把所有的 fit 进去。那这条线是不好的线，因为这个 order 这么大，变成 if you do test data, it will be very different from the training data. So they'll cause a lot of error. So overfitting is meaning you want to find a best curve. Actually, this curve is very high dimension, and this curve will let all your training samples input all the training samples. Your loss will become close to the zero. That's called overfitting. 你就是 training data 进来的时候，你会把所有 training data 放到这条最佳化以后，你会发现你的 loss function 接近零，哎，这是最好啊。但是第二，你说这个不好，为什么 ？Because your test data are very different from your training data。所以这个就是讲这个意思。If you overfitting, it's good for training, but not good for the test. OK， 那 underfitting 是什么 ？underfitting 是什么？就是我还是这些 data， 好，就轻轻踩踩，随便就是一条线把它逼近。所以你的 underfitting is meaning you have a lot of loss error， 你的 error 很大。那 error 当然你的那个 test error 当然更大，就这个每一点就这变成这条线来，蓝色是你的估出来结果，所以你每个 error 就距离就很大，就 error 很大。So we hope is the middle one. We don't want results underfitting. We don't want is overfitting. So we want is the middle one. 那怎么办？那这是我们要解决的问题，就是所以我们的 training data 要给它一些错误，不是最好，我们还是要给它一个错误，一点点错误。那我们这样做 test 的时候才会更好。那这是我们这里要做的事情。好，所以第一个，你的 data 量要多，所以这是我们刚刚讲的 overfit， 要解决 overfitting， 这 data 量要变多，所以把它 flip， 然后 shift 嘛 ，shift 5次，就变5倍，and then flip become 10 times. So we need to in this data augmentation. So we want to create our data. This first method. And create the augmented data the other way. We can use PCA because PCA can do reconstruction. So PCA is the other method. And YOLO V4 talk they have a good explanation for the augmented data. YOLO V4 他在讲这个 augmented data 讲得很好哦，你可以参考一下 YOLO V4 的，他讲这一边讲得很好。好，那最好所以有两个 two solution to solve the overfitting problems. One is augmented data. The second one we call dropout. So that's important. So for the parameter, we need to do dropout. Usually dropout is 50%. So what's the dropout? Because overfitting is because we don't have enough data. And we have large parameters. So can we reduce the parameters? That's a concept for the dropout. Dropout 就是为了让我们的参数的个数减少的意思。叫 dropout。好，那这个一定要用。我刚刚讲到一个 learning rate 的 moment 一定要用到，一个是 dropout 一定要用到。那 dropout 是什么 ？dropout 就是说 50% meaning each time each epoch 你在做 iteration 的时候 ，OK，I drop out suppose 50% is meaning the total parameters I reduce to be half. So suppose your parameters suppose is 1,000. 1000个 parameters。I drop out 50%, is meaning I only use 500 parameters for the training. That's called drop out. 就我只选其中一半的参数来做 training 这样子。那意思是说，剩下一半就不连接啦，就 idle 住不连接这样子，不是等于零哦，是 idle 住就保持原来的值这样子，因为你是 iteration is update 啊。Gradient descent is keep updating your parameters. So drop out is meaning you only update 50% parameters you selected. The other 50% just idle. Just keep the same number of parameters, value of parameters. But in this time, you don't connect that one. 就是忽略掉那50个。这样你的无形中你是不是就你的 training data 就不会 load 就不会那么重，因为你已经把50%的参数已经 idle 住了嘛，叫 drop out. So this can reduce this data problems, and this data problems will cause the overfitting problems. 是这样子啊。So we'll next week, 2 weeks later, we'll keep talking about this one. Okay, so that's it for today lecture. 那下礼拜考试啊，不要想太难，考试没有那么难，都是观念，你曾复习一下，都是观念问题。那 homework need to try to check the homework. Thank you. 谢谢。